Data centers, in their current incarnation, are a far cry from the manual or mechanical switching stations that Ma Bell built just a few generations ago. It's amazing to think that the first coast-to-coast phone call wasn't completed in the United States until 1912, just over 100 years ago. Since that time, technology has accelerated from manual to mechanical to electronic switching stations. Vacuum tubes have been replaced by the integrated circuit, and the number of transistors that can be placed on each microchip has been growing each year since the integrated circuit was first developed in Dallas, Texas in 1958, and has in fact validated the forecast issued by one Gordon Moore in the form of Moore's Law in 1965 that computer power or chip density doubles roughly every 2 years. This has held roughly true since first posited. In 1971, the maximum transistor count per microchip was approximately 2,300. By 2011, that number had increased to 2.6 billion. Yes, B, bravo, billion. This progress, though, is pushing up against physical limitations. Circuits are getting so small and becoming so dense that heat diffusion is a problem. There does exist a theoretical lower limit beyond which no more chips could be forced within the same unit of space, at which point computing power increases would be impossible. Fortunately, humanity, for all its failings, is quite clever. Seeing the limitation in increases in traditional computing power, alternate methods are being investigated. The next step in computing power will come via quantum computers, which will afford far greater computing power at far lower power densities. But a market-ready quantum computer is likely still years, if not decades, away. In the interim, we will have to continue to contend with traditional computing and the opportune challenges and difficulties of massive power and cooling requirements. For the foreseeable future, then, corporations will continue to demand massive amounts of power to operate traditional data centers, though any power conservation opportunities that can be found will translate directly into cost savings for the owner. A common metric within the data center industry is called power usage effectiveness, PUE. This is a ratio of total power used by the data center to power used by the computers on the raised floor. Clearly, insofar as the raised floor area is the only revenue-generating area within the facility, the ideal ratio would be 1.0. That is, all power used within the facility directly drives the revenue-generating computers. The higher this ratio goes, the less effectively a facility is using its power, and the more it's paying for its power, all things equal. By implementing such steps as continuous commissioning or measurement and verification of equipment and loads, an owner or operator can attempt to minimize those loads and associated costs. In the mid-1990s, it was common to find PUEs of 2, meaning only half of the power used in the data center was actually serving the equipment on the raised floor. Within the last few years, employing multiple efficiency techniques simultaneously, large data centers run by the likes of Google, Facebook, and Microsoft have achieved phenomenal increases in efficiencies, with each designing, constructing, and operating data centers approaching or exceeding the 1.1 PUE mark. It's been quite an amazing ride the last 20 years, and the next 20 shows no sign of anything but the same level of innovation and amazement.